Hello learners, are you ready to continue our journey into the history of classification of elements? Look at the modern periodic table. Can you tell the name of element with atomic number 101? Have a closer look. It's Mendelevium. It's named after Dmitri Mendeleev, who is known as father of the periodic table. Even after the rejection of Newland's law of octaves, many scientists continued to search for a pattern that correlated the properties of elements with their atomic masses. Lot of scientists were trying to group the elements and put them in a table. The main credit for classifying elements goes to Dmitri Ivanovich Mendeleev, a Russian chemist. He was the most important contributor to the early development of a periodic table of elements. Mendeleev did something very interesting. Even he must have not known that his method was a path-breaking way of classification of elements. Let's discuss this in detail. It's time to travel back into the era of Mendeleev. You're already sitting in the yellow time traveler bus and slowly traveling from time zone 1866 into 1869. Now you are nearing the third station 1869, named as Mendeleev periodic table. Okay, now till I park the car, you hop down from the bus and go and meet Mendeleev. Have you found him? Oh, you have. Wow. Knock, knock. Hello, sir. Are you Mr. Dmitri Mendeleev, the great scientist who's working on some new way of classifying elements? Yes, I am Mendeleev. I'm working with 63 elements, but I know many more elements will be discovered one day. That's nice, sir. We are a curious bunch of students. Please let us know about your research. Well, I am looking at the relation between atomic mass of elements and their physical and chemical properties. In physical properties of these elements, I can consider melting point, boiling point, and maybe density. And you will ask, what about chemical properties of an element? You tell me, isn't it the ability of a substance to combine with other substance to produce a new substance? And for this I have to do lots of reactions, and this is going to take time. Do you have time? I will need lots of patience. From today onwards, I will do research and find out how these 63 elements react with hydrogen and oxygen. Now you will ask, why only hydrogen and oxygen? Shall I try reactions with others too? No, no, no. Let me choose hydrogen and oxygen. They are very reactive and easily form compounds with most elements. Let me make 63 cards. Here they are. On each card, let me write down the properties of each one of the elements. Look here, I have sodium, and the compound sodium forms with hydrogen is NaH. Let me write it on this card. And the compound sodium forms with oxygen is Na2O, sodium oxide. Okay, now let me make compounds of potassium with hydrogen and oxygen. Compounds formed are KH and K2O. Now let me compare their properties with those of compounds of sodium. Well learners, this was a small glimpse of how you can make your learning interesting and play the role of a scientist. Do role play. Write the dialogues of what he must have thought or done during his research. Okay, so you want me to continue the story of era of Mendeleev? Oh, remember, you are in time zone 1869. Moving ahead now, Mendeleev sorted out the elements with similar properties and pinned these cards together on a wall. He observed that most of the elements got a place in periodic table and automatically got arranged in order of their increasing atomic masses. And as you can see on the screen, it's a wall in a museum in St. Petersburg. A statue of Dmitry Mendeleev, the great chemist and inventor, shown as an old man relaxing with a book in his lap. On the wall behind the monument, a mosaic depicts his most famous contribution to science, the periodic table of elements. Dear learners, you also find out more about him, his childhood, influence of his mother on him, and keep all your collection in portfolio. It's by reading about great scientists one gets inspired to move ahead in adversities also. See, can you see a sketch on the screen of Mendeleev? You must also draw a sketch of Mendeleev and include that too in your portfolio. This way, you can create your own album of scientists. Now coming back to the reaction of sodium and potassium with hydrogen and oxygen. If we represent the metals, that is sodium and potassium, with R, so chemical formula will be same for both RH and R2O. So sodium and potassium have similar properties, therefore they were grouped together. Mendeleev used the formulae of oxides and hydrides to group the elements together. So if you look at the top row of the table, you will see these formulae. The table looked like this. The arrangement of elements he proposed is called Mendeleev's periodic table, and Mendeleev's periodic table was published in a German journal in 1872. As you can see, for group 1, the oxide formula is R2O and hydride is RH. For group 2, oxide is RO and hydride is RH2. So hydride of carbon, that is CH4, what will it be written as? Yes, RH4. And what about oxide of CO2? Search it in the table. Now, horizontal rows are called periods and vertical columns are called groups. It was observed the properties of elements are periodic function of their atomic masses, means elements with similar physical and chemical properties repeat after regular intervals. And if you have a closer look, you will find something very interesting. Do you find some gaps in there? Remember, at that time only 63 elements were discovered. So, Mendeleev didn't forcefully fit elements into his table. Mendeleev left some gaps in his periodic table. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. This was one of the biggest achievement of Mendeleev's table. Mendeleev named the then undiscovered elements by prefixing a Sanskrit numeral, Eka, to the name of the preceding element in the same group. Dear children, note here that at that time in 1869, far away from India, this scientist used Sanskrit word Eka. Don't you feel proud to be an Indian? And yes, And you should take pride in our ancient Indian language Sanskrit. Eka means 1. He named Eka boron, Eka aluminium and Eka silicon and predicted their properties also. And many years later, 3 elements, scandium, gallium and germanium were discovered, whose properties almost matched Eka boron, Eka aluminium and Eka silicon. Now on the screen, you can see the properties of Eka aluminium predicted by Mendeleev and those of element gallium, which was discovered much later and replaced Eka aluminium in the table. Can you compare? They almost match. This provided convincing evidence for both the correctness and usefulness of Mendeleev's periodic table. One more thing to take note is that while developing the periodic table, there were few instances where Mendeleev had to place an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. You know why he had to do this? So that elements with similar properties could be grouped together. Now let us take an example. As you can see, cobalt has higher atomic mass, that is 58.9. It should come after nickel because atomic mass of nickel is 58.7, but it appears before nickel. Since its properties are similar to elements below it, that is, cobalt has properties similar to rhodium and iridium, which are below it, and nickel has properties similar to palladium and platinum, which are below it. So Mendeleev had to make such exceptions. Can you find more exceptions like this? Have a look at the table. That's right, it's tellurium and iodine. If you look at period 5 and group 6 and 7, it has an element tellurium, which has symbol Te and has higher atomic mass than iodine, but is placed before it. One of the strengths of Mendeleev's periodic table was that when these gases were discovered, they could be placed in a new group without disturbing the existing order. Now that we are done with Mendeleev's table, let's look at some of its limitations. Yes, no system is perfect, nor was this table. So first limitation is regarding position of hydrogen. If you look at Mendeleev's table, hydrogen is in group 1 along with other alkali metals, as it shows very similar properties with alkalis. You know why is it so? Look at its electronic configuration. Well, doesn't the electronic configuration of hydrogen resembles that of alkali metals? You can see the electronic configuration on screen. Like alkali metals, hydrogen combines with halogens, oxygen and sulfur to form compounds having similar formulae as shown in the examples. But it also shows similar properties with other elements in group 7, which are called halogens. So just like halogens, it exists as diatomic molecule and it combines with metals and non-metals to form covalent compounds. So where shall we put hydrogen? In group 1 or group 7? Can you assign hydrogen a correct position in Mendeleev's periodic table looking at its resemblance to alkali metals and the halogen family? Come on, try. Certainly, no fixed position could be given to hydrogen in the periodic table. This was the first limitation of Mendeleev's periodic table. He could not assign a correct position to hydrogen in his table. Now, second limitation was isotopes. Do you remember what are isotopes? Let us recall that isotopes of an element have similar chemical properties but different atomic masses. Isotopes were discovered long after Mendeleev had proposed his periodic classification of elements. Now consider isotopes of chlorine, that is Cl35 and Cl37. Would you place them in different slots because their atomic masses are different? Or would you place them in the same position because their chemical properties are the same? So, isotopes of all elements, they posed a great challenge to Mendeleev's periodic law. Now there was another problem, and that problem was that the atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements. Now children, till now, all the classification of elements were based on atomic mass. So elements were arranged in increasing order of atomic mass. You must be wondering why Mendeleev did not use atomic number. If he was having so many issues, he could have used atomic number instead of atomic mass. You will find out about this in the next part. Till then, find out, keeping in mind that Mendeleev gave his table in the year 1869, find out in which year J.J. Thomson identified the existence of subatomic particle, the electron, and how. So just rearrange the events in your mind as to when the different discoveries happened. Now what have you learned till now? Mendeleev arranged the elements in increasing order of their atomic masses and according to their chemical properties. I hope you are noting it down. And Mendeleev even predicted the existence of some yet to be discovered elements on the basis of gaps in his periodic table. And now you can easily classify elements on the basis of their chemical properties, in this case on basis of their oxides and hydrides. And well, children, you can exhibit creativity in designing eco-friendly resources. In this case, it was the time traveler bus, the track, and of course, the 63 cards. You have taken initiative to know about scientific discoveries and also communicate the discoveries in powerful storytelling manner or role play. And now go ahead and put yourself in the role of story writer and find the new ending as to how you would have arranged the 63 elements in 1869. I am sure you can solve the problem by applying the theoretical knowledge you have gathered so far. And don't forget to justify the position of elements. Well, while I drive slowly and roll the bus into another time zone, put on your creative thinking cap and stay happy. Happy learning!